Imagine peering into the heart of a cosmic storm, where the raw forces of nature sculpt matter into intricate, spiraling towers that dwarf anything we know on Earth. Now, thanks to the James Webb Space Telescope, we can witness such a phenomenon in breathtaking detail, a whirling vortex of gas and dust, born from the explosive birth of a new star. This is not a scene from science fiction. It's a real structure, a cosmic tornado, twisting its way through the Chamaeleon I Cloud, 625 light-years from our planet. This is Herbig-Haro 49/50, a rarely seen spectacle captured with unprecedented clarity, revealing secrets of stellar creation and the tumultuous environments that forge planets, comets, and the very building blocks of life. The formation of a star is a violent, chaotic process, and the universe leaves behind spectacular evidence of this cosmic turbulence. As a dense cloud of gas and dust collapses under its own gravity, the core heats up and a protostar ignites, setting off a chain reaction of extreme energy. Not all of the primordial material ends up in the new star. Some clings together, eventually creating planets, while much of it is swept away by powerful jets, streams of plasma that burst forth from the poles of the newborn star. These high-energy outflows slam into the surrounding material at hundreds of kilometers per second, shocking and heating the gas until it glows. The resulting structures, known as Herbig-Haro objects, can stretch for light years, marking the graveyard of past collisions and the birthplace of future worlds. Herbig-Haro 49/50, the cosmic tornado, is one of these dramatic markers. For years, astronomers could only glimpse its true nature through blurred images from older telescopes. When the Spitzer Space Telescope first spotted it in 2006, the scene appeared as a fuzzy, helical lump, intriguing but frustratingly indistinct. The tantalizing shape hinted at immense forces at play, but the details remained hidden. What was sculpting this tower of dust and gas? Was it a single jet or a series of eruptions from a restless protostar? And what lay hidden in its shadows? With the launch of the James Webb Space Telescope, a new era in astronomy began. Webb's primary mirror is more than 6 times the size of Spitzer's, and its sensitive infrared instruments can pierce through veils of dust that block visible light. Now, with its powerful gaze, Webb has transformed our understanding of this cosmic tornado. The once blurred structure now resolves into a sharp, dazzling column of material, wound into a helical shape by the relentless force of stellar winds and plasma jets. At the top of the image, what appears to be a glowing cap is in reality a distant spiral galaxy shining from far beyond, its light coincidentally aligned with the chaos of HH 49/50. The view is not just a triumph of technology, it's a window onto processes that have shaped the universe for billions of years. Every element of this scene is a clue. The glowing filaments trace the path of supersonic shocks. The ribbons of dust and gas, illuminated by ultraviolet light, reveal the ingredients from which new planets might someday form. And the tornado-like twist speaks to the turbulence and magnetic fields that influence star and planet formation on cosmic scales. But there's more to this image than meets the eye. The JWST's incredible sensitivity reveals a hidden population of objects scattered across the field. Some of the bright dots, which at first glance seem to be mere specks of dust, are actually entire galaxies, each containing billions of stars shining through the foreground maelstrom like distant beacons. Others are lone stars, their sharp points of light standing out against the diffuse glow. The cosmic tornado itself is a foreground phenomenon in our own galaxy, while the background galaxies are vast, independent structures separated by incomprehensible distances. This chance alignment creates a sort of natural laboratory, allowing astronomers to study multiple layers of the universe in a single image. For scientists like Macarena Garcia-Marin, an astrophysicist at the European Space Agency, this image is a rare and fleeting glimpse into one of the universe's most energetic moments. The cosmic tornado is not a permanent monument. As the central protostar continues to grow, its jets will eventually fade, and the intricate tower of dust and gas will disperse into the interstellar medium. In cosmic terms, this is a brief event, an astronomical blink, lasting only a few tens of thousands of years. What we're seeing is a snapshot, frozen in time by the JWST's eye, of a process that has created countless stars and planets throughout the Milky Way. But why does this matter? What can a swirling tower of dust, light years away, tell us about our own place in the cosmos? The answer lies in the physics of star formation and the origins of planetary systems. When a protostar forms, it gathers material from a surrounding disk of gas and dust. This accretion process is messy and inefficient. Much of the material falls onto the growing star, but some is ejected in those powerful jets, carrying away angular momentum and helping the disk flatten out. The remaining dust can eventually stick together, forming planetesimals, the seeds of planets, moons, and asteroids. By watching objects like Herbig-Haro 49/50, astronomers can witness these processes in real time. The orientation and structure of the jets reveal details about the magnetic fields threading through the disk. The speed and composition of the outflows shed light on the chemistry of the early solar system, and the interaction between the jets and their environment can trigger further waves of star formation, setting off a cosmic chain reaction that seeds future generations of stars. Webb's infrared vision is crucial to this detective work. In visible light, the thick dust of star-forming regions blocks our view, but in the infrared, the dust becomes nearly transparent, allowing astronomers to see deep into the heart of these turbulent nurseries. This is why the JWST is a game-changer for studies of star and planet formation. Its images are not just beautiful, they are packed with data, revealing the physical conditions, chemistry, and dynamics of the universe's most fertile environments. And the surprises don't end there. The cosmic tornado is only one of many Herbig-Haro objects revealed in exquisite detail by Webb and other modern telescopes. Each has its own story, its own unique shape sculpted by the forces at work in its region of space. Some are double jets, shooting out in opposite directions like cosmic fire hoses. Others curve and twist, shaped by the motion of their parent stars through the galactic medium. All are evidence of the universe's ceaseless creativity, its ability to build complexity from chaos. As we study these phenomena, we are also looking back in time. The light reaching us from HH 49/50 began its journey 625 years ago, before the telescope was even dreamed of, before Galileo first pointed his primitive lens at the stars. Every pixel in Webb's image is a message from the past, a record of conditions and events that occurred centuries before our own story began. This perspective brings a sense of scale and wonder that is both humbling and exhilarating. The structures we see today are echoes of processes that have played out billions of times across the cosmos. Our own sun and planets were once part of a similar drama, a star's birth surrounded by swirling dust, jets of plasma, and the seeds of future worlds. By deciphering the language of these cosmic tornadoes, we piece together the story of our origins. Yet, as detailed as these observations are, they raise as many questions as they answer. What triggers the onset of these powerful jets? How do magnetic fields guide and shape their path? What determines whether a disk of dust will form rocky planets like Earth, or gas giants like Jupiter, or perhaps nothing at all? Each new discovery is a step forward, a deeper dive into the complexity of the universe, and a reminder of how much there is still to learn. With each image from Webb, astronomers are building a more complete picture of the life cycle of stars. From the collapse of cold, dark clouds, to the brilliant outbursts of newborn stars, to the assembly of planets and the dispersal of debris, we are witnessing the universe in action. The cosmic tornado of HH 49/50 is not just a beautiful object. It is a key to understanding how the cosmos recycles its raw materials, forging new generations of stars and planets from the remnants of the old. In the end, the story of the cosmic tornado is the story of cosmic evolution itself. The same forces that shape these distant structures are at work in every corner of the universe, including our own solar system. By studying the birth pangs of stars in the Chamaeleon I Cloud, we are exploring the origins of worlds, perhaps even life, across the galaxy. And as the JWST continues to peer deeper into the universe, unveiling scenes of staggering beauty and complexity, we find ourselves at the dawn of a new era. Every image, every spectrum, every discovery brings us closer to answering the most profound questions. Where did we come from? How did stars and planets form? And what other wonders await us hidden in the swirling dust of distant star nurseries? The journey has only just begun.